All right, so lesson 35, transformations of sinusoidal functions. Okay, so that's going to be sine graphs and cosine graphs, by the way, sinusoidal functions. So we've done this tons now, right? There's just going to be a couple of little differences, but it's still going to follow our basic formula, right? The one right on your formula sheet. And actually, on your formula sheet, you even have it broken up into sine and cos, like we did in the last lesson. I'll show you below too. But we've still got A, we've still got B, C, and D, right? Difference here, though, is that we're going to have this, right? We're going to have the period is equal to 2 pi over 2 pi over B. But yeah, other than that, it's going to be really similar. So I think let's just get right into it. Examples are the best part here. So this one just says simply sketch the graph of the function y is equal to that mess, right? Showing at least 2 complete cycles. Describe the transformation, state the domain and range. All right, so, well, in order to sketch this one, we again need to compare it to the base function. Okay, so the base function here is y is equal to, and it'd be a sine, and then b, and then you could say x or you could say theta. In this case, they've written theta, so I'll say theta plus, or no, it's minus. The original equation is minus c, and then plus d, right? So that should look pretty familiar. All right, so now let's just write that one below it so we can see what our a and b and everything else is, right? So we've got y is equal to 5 sine b, oh, sorry, b is 0.5. Theta plus pi over 2 plus 3. Okay, so the way we're going to do these, let's sketch out just the original graph, like first off, of y is equal to sine x, right? Because this really is the transformation of that. Okay, so if we remember what that looks like, it kind of sucks because our line doesn't line up right here, or like our y-axis, but remember a sine graph, right? That one actually starts, I'll make this my point, at 0, right? Because you remember why that is, because sine, if you're doing your unit circle, you have to draw this, but sine was your y coordinate, right? So at that point here, this would be the point 1 comma 0. So sine it starts its journey here at 0, right? So a sine graph starts right there. Then it has a period of 2 pi, right? So what I'm going to do, I'm going to write down every 2 ticks, I'm going to make pi. So I'll go pi there, and then 2 pi, and then we've got 3 pi, 4 pi, 5 pi, and 8 pi. Okay. Now I'm just going to make one little tick on here because I can see this thing is going to go up 3, and it's going to make it, it's going to be really stretched up and down by 5. So that's kind of how I'm getting a feel for like how big or how much room I need to leave myself here. So I'm going to make it like 1 just right at that first tick here. So that's going to be 1, and that'll be -1. All right, so if we were going to sketch just the graph of y is equal to sine x, then, and it says for 2 complete cycles, I'm going to start there, and then it's going to pass through here, right? And it's going to go up to 1 in the middle. So it's going to go up there, and then down, and then up. That'd be 1 cycle, right? That'd be 1 time through the circle. And then it says 2, so I'm going to do, I'll keep going here. So then it goes up, and then down, and then up, right? So there's my sine graph. All right, so now what we're going to do, we are going to figure out what our new graph is going to look like. Now, you can do this different ways. You can actually just kind of break it up piece by piece and draw your graphs all the way along the way. I really prefer for you guys to figure out the mapping notation and then just change the points, put the points where they go in the end. So let's do that. Let's figure out what our horizontal translations, all that kind of stuff are, right? Horizontal, vertical, everything else. Okay, so we know that we have a vertical stretch of 5, right? That's what that A value really is. Okay, so we got a vertical stretch of 5. We've got, okay, so now I'm not exactly sure what that thing is yet, right? Well, you know, we can't, let's just write it this way. So we'll say that was normally 1/2, right? A half. So remember your B value, it's still flipped, right? So this is actually going to be a horizontal stretch of 2, right? Or 2/1. Okay. So we got that one figured out. Now, while we're doing that, horizontal, well, no, you know what? I'll come back to it. I'm not going to confuse things yet. We'll just stick to that. So horizontal stretch of 2. Okay, now let's look at this one. So our C value, what's that telling us? That's telling us that we have a horizontal translation of pi/2 to the left. Okay, and then we have a vertical translation of 3 up. All right, so there's the 4 things that are happening, okay? So now what I'm gonna do is I'm gonna turn this into mapping notation. So let's say any point on the original function, so on our red graph over here, so we can say x, y, any point is gonna turn into, and then let's just apply these things, right? So that's gonna be so looking at my x values first, those would be my horizontal stretch and horizontal translation. So that'll be 2 times x. And then since this goes left, this will be minus pi/2. Oh. And this always confuses people. It actually is minus, right? It's the opposite in the equation. It's the way it actually is in the mapping notation, right? So it really is 2 and pi/2 to the left, okay? Okay, so there's our x. Every x value is going to undergo that transformation, right? So all I got to start doing is throwing x values into that. Okay, and then the y values. So 5, right? Because it's going to be a vertical stretch of 5 times whatever the y value was. And then it's going to be 3 up, so plus 3. There's our key, right? We have a key to this question now. Now we can just start throwing points in and plotting them, essentially, right? So let's throw in an easy one. Let's throw in the point. I'll do these different colors. Let's throw in this point, right? 0, 0. So we'll throw in the point 0, 0 and see what happens to that. All right, so that would be 2, and then instead of an x, I'm going to put a 0 in, minus pi/2, and then the 5 times 0 plus 3. All right, so the point 0, 0 would turn into the point negative pi/2, comma, and then 3. All right, so that's our first one, right? I know that this point that was at 0, 0 is now going to be at the point negative pi/2. Okay, so where's negative pi/2? Remember, pi/2 would be right in the middle of pi, right? But we're on the negative side, so we're going to be over here. So it's going to be at the point negative pi/2, so just one box over, and then up 3. So there's my new point. That's where that one ended up. Okay. So now let's do the next one. We're not going to have to do all of them. We're only actually going to need like 3 at most to kind of get the like how this thing's going to look. And I'll show you once we get those 3 points, then you can just kind of keep drawing it. So, all right, so there's that one. So now let's do the point. You know what I'm going to do? I'm going to do like the point we just did, this point and this point, and see where they go. Because once I have those 3, then I've pretty much got it. Okay. Just for simplicity though, I think I'm going to do this one first and then the peak there. So let's see where this point goes. All right, so where is that point to begin with? That is the point pi, comma, 0, right? So where does the point pi, comma, 0 go? So putting it back into my mapping notation up there, that would be 2 times pi minus pi over 2. And then comma, and then my y value is easy because it's 5 times 0 plus 3. Okay, so this thing is going to become, so the point pi, comma, 0 would become, so now this one is, so you'd get, here, let's write it down, just to remind you guys. So if we had 2 pi minus pi over 2, you'd need common denominators, right? So I'd multiply the bottom by 2 and the top by 2. So that would be the same as 4 pi over 2 minus pi over 2. That would be 3 pi over 2, okay? So that's what this is going to turn into, right? So this point is now 3 pi over 2. And then my y value is 3, right? 5 times 0 is 0, plus 3 is 3. So there's my new point, right? So pi, comma, 0 turns into 3 pi over 2, comma, 3. Let's see if that makes sense, because it should kind of make sense. So 3 pi over 2 is not quite at 2 pi, right? It's right in the middle again. So that's going to be here is my x value. And then my y value, again, is up at 3. And that makes sense, right? Because they should be in a line. They were in a line here and here, and they're going to be a line in the top. So that one makes sense. Now my next point here, I'm going to see where this one ends up. And I already really know that it should line up in between these 2 points, right? It's going to be like up here somewhere, right? But where is it? So I just got to do it one more time and get that point. And then when I do that, I should be pretty good just to sketch the whole thing out. So let's do that one. So we'll say, okay, where does the point, all right, so now this point, the purple one there, that's the point pi over 2, comma, pi over 2 because it's in between these, right? So pi over 2, comma, 1, y value of 1. Where does that one go? All right, so let's say, so again, I'm just looking back to my key here. That's going to be 2. My x value is pi over 2 minus pi over 2. And then comma, and then 5 times 1 plus 3, because that's my y value. All right, now just simplifying that up again, the point pi, comma, 2, comma, 1 turns into, all right, so this is really pi over, 2 pi over 2 minus pi over 2. That's just, so 2 minus like 1 here. It's like it already has a common denominator, right? So I can just call that 1 pi, or pi over 2, right? So that's what that whole top thing turns into. And then comma, and then 5 times 1 is 5, plus 3 is 8. So there you go. There's my next point. So the next point here should be at pi over 2. See if that makes sense. And yes, it does. Pi over 2 would be right in between 0 and pi. So my x value makes sense there. And then it's going to be at 8. So 1, 2, 3, 4, 5, 6, 7. So it's all the way up there. Okay. And like I said before now, we're pretty much done. Like we've done all the hard work, I think, because now we can just sketch this thing. Because, well, here, if I connect the dots here, so this would come up and then go down. This thing's going to follow a pattern here, right? That looks gross. I'm going to make that black. This is going to follow our pattern, right? Because here's our midline. This thing would be like right there all the way across, right? So then this would go, well, can you see it's like every 4 blocks, right? That's like 4 blocks from like here to here, right? Really what I can do is I can go 4 more blocks. I can go 1, 2, 3, 4. So it's got to come back up again there. And then I know that the midline is going to be between these, or like not midline, the middle point between is going to be between those. So that's going to be, and it's going to be, well, it's 1, 2, 3, 4, 5 up. So it's going to be 1, 2, 3, 4, 5 down, right? The whole thing's symmetric, right? Like you can use like a bit of your logic to figure out, how the whole thing will end up being symmetric. And then back up again. And there you go. So there's our sine graph. It did say 2 full complete cycles. So we'll just keep going. So we'll just keep doing this pattern here. So it was 4, to that point, and then 4 more, it'll cross again there. And then in the middle, it'll come up to here. And then in the middle down here, it'll come down to here, right? So there's my points. Now I just connect the dots. Oh, shoot. Oh, deleted a bunch of things. Okay. And we're done. All right, so there you go. I know it seems like a lot of work, right? But just to recap this, right? We just figure out what our transformations are. We put that into mapping notation, and then we just figure out where each point goes. Okay, and yeah, that's pretty much the gist of it. So hopefully you guys are doing all right with that one. All right, so number 2. So number 2, they say write an equation in each of the forms. So now they've given us the form in the form of sine and the form of cosine, right? They're exactly the same other than the cos and the sine of that. And they've given us this graph. So the idea here is you can actually write this graph actually an infinite amount of ways. I'll talk about that in a second, but you could talk about this as originally being a cos graph or originally being a sine graph. It actually will work out either way. So A and B and D will really be the same for all of them. So, well, A might be a little different. It might be negative or something, but yeah, let's just go through it. So let's figure out what A is in either case. Let's find what we're looking for here. So A, so what's this gonna be? So if you remember A is your amplitude. So if I had like a dotted line going across the middle there, right? When I say A, I mean this, right? That's how high up and down it is. And normally the height of this thing is at 1, right? It only ever goes up to 1 to begin with. So the amplitude really is your vertical stretch factor as well, right? Because if this thing, let's say it's at 3 now, and it was at 1, then this thing was multiplied by 3. So A really is your vertical stretch factor, by the way. So either way, A can be found by this equation. You can say it's your max minus your min divided by 2. Okay, so remember what that means. That's like your max minus this and then dividing it by 2. That's just really, finding, so this minus this would get you the whole length, and then dividing it by 2 just gets you the 1. It's a little bit more confusing sometimes when you're like into the negatives, because now we're gonna like subtract a negative and everything, but the equation still holds true. Like it's still always gonna be correct. So let's do it. So we'll say A is equal to max, so the max here, the max Y value is negative 0.5. And then minus, and then negative 1.5 divided by 2. Okay, so our A value is negative 0.5. Okay, so now it comes out as negative 0.5, but technically, we could have called this the absolute value because it doesn't really matter with the negative there. It's true, it could be negative because remember what a negative would mean on the front of that? It would mean that the whole thing got flipped upside down, which it kind of did. You can think about it that way, right? Because normally a sine graph would go like up to begin with. This one, if I'm starting right at the beginning, it's going down to begin with. So that would actually work out. I might keep it as negative when I do it, right? So it can be positive or negative, but the context will matter when we start putting it all together. So let's just keep that in mind for now. So we've got A is equal to negative 0.5 or 0.5, like either one, okay? So now moving on to the next one. So we'll say D. So we got to figure out what D is. So D is going to be max plus min divided by 2. And remember what that means, right? So max plus min divided by 2, that's the average. That's what that's finding. That's finding the average between your top and your bottom is all that's doing, right? So let's put those numbers in. And again, it's a little bit more confusing with the negatives, but it's still true. So if we had negative 0.5, so our max y value, plus negative 1.5, so our minimum, divided that by 2, then we get a d value of negative 1. All right, we're piecing it together. We got two of the pieces already. So now let's find our b value. So our b value would normally be like, how much did the thing get stretched one way or the other? And it's kind of hard to, this is the thing with sine functions. It's like when we did our other functions, you could see like, how much did this thing get stretched one way or the other, right? So let's say the original one was up here and it got stretched to there or something. It's really hard to see on a sine and a cosine function. And I don't really want to deal with like decimals if I don't have to. I'd rather kind of have it written with like pi, right? So it's not an irrational, well, it's still an irrational numbers, but so it's in a more accurate form. Okay, so what we want to do here for sine functions is I want to use my little equation that we learned in the last lesson, that b is equal to 2 pi over p, right? 2 pi over, and then p is the period. So the period of the function. Okay, so then this, so I can find this just using this little equation. I just got to figure out what the period is. Okay, so let's figure that one out. So the period is how long for the wave to repeat the pattern again, right? So that would be from like here to, let's say, here. So they didn't really give me very great numbers because this is like, 3/4 of the way would give me that number. I'm not really going to go that direction, I think. I think what I'm going to do here is I know that from here to here, that's half of a wavelength, right? Because from here to here would be one full wavelength. You guys kind of get that? So if that's half a wavelength, all I have to do to figure out my period, so p, that's just going to be 2.62 minus 1.57, right? To figure out the difference or the distance from there to there, and then just times 2. Okay, so your period ends up being 2.1, which is kind of annoying, but it just doesn't work out that nice. But we'll kind of round a little bit. So 2.1. So then we can just use our equation for b. So we can say, okay, well, b is 2 pi over our period, which is 2.1. And if you put that in, you get like 2.99 something. So I'm just going to call that 3. I'm going to round that up to 3. There we go. We've got 3 of them. We just need one more. We just need our c value. So I'm actually going to start writing it out so you can see it. So let's go y is equal to, and here, I'm going to write out just the general equation first. So a sine b, and then x minus c, and then plus d. Okay, so I'm going to write this out now using sine. So we said a was equal to negative 0.5, right? So that's what we said up here. And a was our amplitude, right? So now let's just get our bearings of what we're actually saying here. Sine, remember, normally starts at 0, right? Like it crosses the y-axis at 0, like it's doing now. Okay? And normally, though, it goes up. A sine graph starts going up and then down and then up and then down. So I can see that this graph, you could think about it this way, that the graph has actually just been flipped upside down. So that negative did that, right? So that already handled that for me. And so I'll just leave it like that for now. So it's negative 0.5 times sine. Our b value, we said, was 3. And then x, and then we haven't figured out c, right? But this is where the context matters, where we have to look at the graph and figure out what we think happened. There's actually an infinite number of things you could put in for c that'll all be true. But let's just find one of them here. So in this case, we're saying that we just flipped it upside down. So then I haven't moved this thing left or right at all, right? It's stuck in the same place. So in this case, I'm good, right? There is no, it's not going left, it's not going right. I'm just going to close that bracket, or plus 0 if you like, that doesn't matter. Okay, so that's good. There's that. And then our D value, it's probably the easiest one, right? We found that our D value is -1. So just -1. So there you go. There's our sine function. But I just want to show you that I could have thought about that different, right? It also would have been true to say y is equal to 0.5 times, instead of negative, right? So I'm going to make that positive 0.5 times sine, and then that'd be 3. And then now think about what happened here though, right? So what I'm saying in this case is that I took my original function that would have been going up to begin with, right? And then like down again, up to begin with, and then like, getting terrible at this, okay. Down again, okay. So normally the thing would have started right here, right? But what we're saying is this thing has been shifted to the right all the way to this point. Okay, so that would be true. Now that point, how would you find that? Well, that would just be 1.57 divided by 2. That would get you there, right? So I'm going to write that 1.57 divided by 2, which is 0.755. Okay, so yeah, so it's just been shifted 0.755 to the right. Okay, so I could write that here. So that would be to the right. So that would be minus 0.755, right? Minus means it's going the other way. So you see how that's different, right? It was like if I think about it as like starting, like going up, then I had to shift it to get it there. But if I like flipped it right off the bat, I didn't have to shift it at all. So like I said, context matters here. And then, sorry, so we'll finish this. So then it's still -1. D will always be the same. Okay, now those are two of the infinite ways, because I also could have thought about this thing as shifting not to here. I could have thought about it as shifting all the way to there, or shifting all the way to there, or all the way to there, or even backwards, right? I could have thought about this, like I said, an infinite number of ways. Typically, you would just go to the closest one, though. But okay, anyway, we're getting there. We're almost done. So let's do our cosine graph now, though. So y is equal to, I'm going to make it positive 0.5. I could do it negative, but I'll do it positive. Times sine, cosine, sorry. Cosine. And then it's still going to be 3, because that's my stretch factor, right? Like that's always going to be the same. And then x, and then what's going on here? Okay, well, normally a cos graph starts at the top, right? It starts right there, right? Because it's at the point 0, 1 to begin with on a cos graph, if you remember, right? And then it would come down, right? So this thing shifted from there to there. Okay, so how do I shift from 0 to 1.57 to the right? Well, I have to go minus 1.57. Close my bracket, and then it's still 1 for my D value. And again, I could have shifted it all the way to there, or I could have went the other way. I could have shifted it to there. But those are all true, right? Those will all be the same thing. But if you typed all of these into your calculator, you wouldn't be able to tell the difference. They're all exactly the same graph. All right, so we actually kind of started harder, and we're just getting easier as we go. So this last part won't take long at all. So it says write the equation of each cosine function in this form, given its characteristics. So it says an amplitude of 2. Okay, so amplitude of 2, that's easy. I'm just going to put a 2 in there. So y is equal to 2 cos, and then it says it has a period of pi. That's where I'm going to get my b value from. Okay, so I got to find that one out though. So let's figure out what b would have to be there. So we'd say b is equal to, and then it's going to be 2 pi over period. Okay, so that's going to be 2 pi over pi. So our B values 2. They cancel. We're left with 2 there, right? And then X, and then it says shifted pi over 3 to the left. So to the left, that's going to be plus pi over 3. And then vertical displacement of 1 down, so minus 1. And there you go. Okay, next one here says amplitude of 1 over 4. So we'll say y is equal to 1 over 4 cos. Now my B value, right? So the period is 540 degrees. So that's going to look a little different. So B is equal to, it won't be 2 pi over 540 this time, right? Because now I'm talking in degrees. The degrees version of 2 pi is 360, right? So it's going to be 360 over 540, which would simplify down to 2 over 3. Okay, so that's my B value. So we got 2 over 3 x minus 6, or x, and then a shift of 60 to the right, so minus 60. And then plus 2. Vertical displacement of 2 up, so plus 2. So there you go. And we're done.